Reading comprehension. The ability to understand and interpret what is read. Main ideas. Central point or message an author wants to convey. Themes. Central message, lesson, or universal truth that an author conveys through a literary work. Analyze the conflict. How do the characters resolve their primary struggle? This often points to the lesson learned. Examine character growth. How do the protagonist's beliefs or behaviors change by the end of the story? Identify motifs and symbols. Recurring images or objects often reinforce the central message. Good versus evil. The struggle between right and wrong. Coming of age. The transition from childhood to adulthood and the loss of innocence. Identity. The search for self and personal transformation. Power and corruption. How authority influences individuals and societies. Survival. Resilience in the face of physical or emotional hardship. Justice. The exploration of fairness, law, and morality. Fate versus free will. The conflict between destiny and personal choice. Author's purpose. Make readers think, feel, or act a certain way, or simply to enjoy a story. Persuade. To convince the reader to agree with an opinion, take an action, or buy something. Inform. To teach or provide facts about a topic. Entertain. To provide enjoyment, humor, or excitement through fiction, fantasy, or mystery. Describe. To paint a vivid picture using sensory details. Explain/instruct. To guide the reader through a process with steps. Text structures. Different ways to organize information in writing. Description. Details, features, characteristics, or examples of a topic. Sequence/order. Present steps, events, or items in time order. Compare and contrast. Shows similarities and differences between two or more things. Cause and effect. Explains reasons why something happens and its results. Problem and solution. Presents a problem and then offers one or more solutions. Interpreting meaning from context. Using surrounding words and sentences to figure out an unknown word's definition. Grammar. The set of rules that govern the structure of sentences. Parts of speech. Categories of words based on their function in a sentence. Complete sentence. Needs a subject and a verb, and must express a complete idea. Independent clause. A complete sentence. Dependent clause. Has a subject/verb but isn't a complete thought. Quantitative reasoning. Application of basic math skills to interpret and analyze real-world quantitative information. Whole numbers. A set of numbers that includes all natural numbers and the number 0. Fractions. Represents a part of a whole or a division of one number by another. Proper fractions. The numerator is smaller than the denominator. Improper fractions. The numerator is equal to or greater than the denominator. Mixed numbers. A combination of a whole number and a proper fraction. Equivalent fractions. Different fractions that represent the same value. Addition and subtraction. Requires a common denominator. Once denominators are the same, you add or subtract the numerators while keeping the denominator constant. Multiplication. Multiply the numerators together and the denominators together. Division. Multiply the first fraction by the reciprocal of the second fraction. Simplification. Reducing a fraction to its lowest terms by dividing both the numerator and denominator by their greatest common factor. Decimals. Standard way of representing numbers that include values between whole numbers. Tens. The first digit after the decimal. Hundredths. The second digit. Thousands. The third digit, and so on. Terminating. Decimals that have a finite number of digits. Repeating. Decimals where one or more digits repeat in a pattern forever. Non-repeating/non-terminating. Decimals that go on forever without a repeating pattern, such as pi 3.14159. Addition and subtraction of decimals. Align the decimal points vertically before calculating. You can add placeholder zeros to make the numbers the same length. Multiplication of decimals. Multiply as if they were whole numbers. Count the total decimal places in the original numbers and place the decimal point in the answers so it has that same total. Division of decimals. Move the decimal point in the divisor to make it a whole number, then move the decimal in the dividend the same number of places before dividing. Ratios. Mathematical comparison of two or more quantities, showing how much of one value is contained within another. Colon notation. 3, 4. Fraction notation. 3/4. Word form. 3 to 4. Simplification of ratios. Like fractions, ratios can be reduced by dividing both terms by their greatest common factor. For example, the ratio 10:20 simplifies to 1:2. Order matters in ratios. The order of numbers must match the order of the items being compared. Part-to-part ratio. Compares two distinct groups. Part-whole ratio. Compares one group to the entire total. Proportions. A statement that two ratios are equal is called a proportion. Cross multiplication. The product of the extremes A and D equals the product of the means B and C, so add equal BC. Finding an unknown in proportions. If one value is missing, cross-multiply and solve for the variable. Direct proportion. As one quantity increases, the other increases at the same rate. Inverse proportion. As one quantity increases, the other decreases. Percentages. Number or ratio expressed as a fraction of 100, often denoted using the symbol percent. Find percentage of a whole. Times 100 equal percentage. Find value from percentage. Percentage times whole equal part. Find percent change. New value, old value divided by old value times 100 equal percent increase/decrease. Geometric measurements. Quantifying the physical dimensions and attributes of shapes and spaces using standardized units. Area. Quantifies the size of a flat surface or two-dimensional shape in square units. Volume. Measures the space occupied by a three-dimensional object in cubic units. Perimeter. The length of the boundary of a two-dimensional shape. Diameter. Straight line segment that passes through the center of a circle or sphere and connects two points on its edge or surface. Angles. Measures the openness between two intersecting lines or rays at a vertex. Zero angle. 0 degrees. Acute angle. Between 0 degrees and 90 degrees. Right angle. Exactly 90 degrees. Obtuse angle. Between 90 degrees and 180 degrees. Straight angle. Exactly 180 degrees. Reflex angle. Between 180 degrees and 360 degrees. Full rotation. Exactly 360 degrees. Adjacent angles. Share common side and vertex without overlapping. Complementary angles. Sum to 90 degrees. Supplementary angles. Sum to 180 degrees. Vertical angles. Opposite angles formed by intersecting lines that are equal. Pythagorean theorem. Used to find a missing side length in a right-angled triangle. Protractor. A standard tool used to measure or draw specific angles. Coordinate geometry. Uses a grid system to determine precise positions and distances between points. Linear equations. Algebraic equation where each variable has an exponent of 1, resulting in a straight line when graphed. Quadratic equations. Second-degree polynomial equation in the standard form x2 plus bx plus c equals 0. The quadratic formula. X equal b plus minus square root slash 2a. Inequalities. Less than, greater than, less than or equal to, greater than or equal to. The negative rule. If you multiply or divide both sides by a negative number, you must flip the inequality sign. Inequality sign flip. If you multiply or divide both sides by a negative number, you must flip the inequality sign. Open circle. Use an open circle for less than or greater than. Closed circle. Use a closed circle for less than or equal to or greater than or equal to. Shading on number line. Shade the number line in the direction of the solution. Polynomial. Mathematical expression with variables, coefficients, and non-negative integer exponents, combined using addition, subtraction, and multiplication, but not division by a variable. Terms in polynomials. Terms are separated by plus or signs, and polynomials are named by their term count. Coefficient. The number multiplying the variable. Variable. The letter. Exponent. The small number indicating repeated multiplication. Constant. A number with no variable, which is a term with an exponent of 0. Independent variable. The input value that is changed or controlled in an equation or experiment to see how it affects another value. Dependent variable. The output value that changes in response to the independent variable. Continuous variable. A variable that can take on an infinite number of values within a range. Discrete variable. A variable that can only take on specific, distinct values, often whole numbers. Parameter. A variable that remains fixed for a specific problem or case but could change in a different context. Operators. Symbols like plus and equal. Monomial. Single algebraic term that is a product of a constant and one or more variables raised to a non-negative integer power. Binomial. Two-term algebraic expression. Binomial theorem. A formula to expand powers of binomials, like a plus b using binomial coefficients. Trinomial. Polynomial with exactly 3 terms. Function. Relation where every input has one unique output. Graph intersections. If any vertical line intersects a graph more than once, the graph does not represent a function. Intersects. Points where the graph crosses the x or y axis. Increasing/decreasing. Intervals where the graph goes up or down from left to right. Maximums/minimums. The highest or lowest points on the graph. Domain. The set of all valid input values for a function or equation that produce a real output. Range. The set of all possible output values a function produces. Bar graphs. Use bars to compare quantities. Line graphs. Connect data points with lines to show trends over time or continuous data. Pie charts. Show parts of a whole. Xi plots show relationships between two variables. Mean, the arithmetic average of all numbers. Median, the middle value when the data is arranged in order from smallest to largest. Mode, the value that appears most frequently in a dataset. Range, helps determine if a dataset is tightly clustered or widely spread out. Circulatory system, it transports oxygen, nutrients, and hormones to cells while removing waste. Respiratory system, facilitates the exchange of oxygen and carbon dioxide between the body and the air through the lungs and airways. Lymphatic system, drains excess tissue fluid and defends the body against infection and disease-causing agents. Digestive system, digestive system, breaks down food into nutrients for energy and eliminates solid waste via the gastrointestinal tract. Urinary system, filters blood to produce urine, maintaining fluid, electrolyte, and pH balance. Reproductive system, includes organs necessary for producing offspring, such as ovaries and testes. Tropical rainforest, known for high rainfall and warm temperatures year-round, supporting the greatest biodiversity on Earth. Desert, defined by very low precipitation, with plants and animals specifically adapted to conserve water. Tundra, a cold, treeless plain found in Arctic regions or at high altitudes, characterized by permafrost. Taiga, the largest terrestrial biome, consisting mainly of coniferous evergreen trees and experiencing long, cold winters. Grassland, dominated by grasses rather than large shrubs or trees. Includes temperate grasslands and tropical savannas. Temperate forest, regions with 4 distinct seasons and a mix of deciduous and coniferous trees. Savanna, tropical grasslands with scattered trees and distinct wet and dry seasons. Chaparral, a scrubland biome with hot, dry summers and mild, rainy winters. Energy flow, arrows in a diagram point from the organism being eaten to the consumer. The 10% rule. On average, only about 10% of the energy from one trophic level is passed to the next. The remaining 90% is lost as heat or waste. Ecosystem stability. High biodiversity typically leads to a more stable food web. Trophic cascades. Removing a single species, especially a keystone species like a top predator, can cause a cascade of effects that disrupts every other level in the web. Producers. The foundation of the web, typically plants or algae that create their own food through photosynthesis or chemosynthesis. Primary consumers. Animals that eat only producers, such as rabbits, deer, or zooplankton. Secondary consumers. Carnivores or omnivores that eat primary consumers. Tertiary consumers. Predators that eat secondary consumers, often apex predators with no natural predators of their own. Decomposers and detritivores. Decomposers and detritivores. Genes. Fundamental units of heredity, segments of DNA that carry instructions for building and operating an organism. Transcription. The cell makes a copy of a gene's DNA sequence in the form of messenger RNA. Translation. This mRNA travels out of the nucleus to a ribosome, which reads the code to assemble a chain of amino acids into a specific protein. Gene expression. Not all genes are active at once. Cells turn on or turn off specific genes depending on their function. Gene count. The human genome contains approximately 20,000 to 25,000 protein-coding genes. Variations. Different versions of the same gene are called alleles, responsible for differences between individuals. Mutations. Permanent changes in the DNA sequence of a gene, which can lead to genetic disorders. Epigenetics. Studies how behaviors and the environment can cause changes that affect how genes work without altering the underlying DNA sequence. Nucleotide. A single unit consisting of one sugar, one phosphate, and one base. Genetic blueprint. The sequence of bases along the backbone encodes biological information, similar to letters in a book. Traits. Specific characteristics determined by genes, which can be qualitative or quantitative. Genotype versus phenotype. Your genotype is your actual DNA sequence, while your phenotype is the observable trait. Nature versus nurture. Environmental factors significantly influence how many genetic traits manifest. Predictive models. Companies like Ancestry DNA and 23andMe use polygenic risk scores to estimate your likelihood of having certain traits. Evolution. Fundamental biological process where living organisms change their heritable traits over successive generations. Natural selection. Core mechanism of evolution where organisms better adapted to their environment survive and reproduce more successfully. Stabilizing selection. Favors the average version of a trait and selects against extremes. Directional selection. Favors one extreme of a trait, causing the population to shift in that direction. Disruptive selection. Favors both extremes of a trait over the average, which can lead to the formation of new species. Variation. Individuals in a population have different characteristics, such as size or color. Inheritance. Inheritance. Traits must be heritable, meaning they are passed from parents to offspring via genes. Overproduction. Most species produce more offspring than the environment can support, leading to a struggle for existence. Differential success. Individuals with advantageous traits are more likely to survive and reproduce. Adaptation. Trait that helps an organism survive and reproduce in its environment. Structural. Physical features of an organism's body. Behavioral. Actions organisms take to survive. Physiological. Internal processes or chemical responses. Human health. Body functions including movement, nutrition/metabolism, respiration, circulation, coordination and control, protection and immunity, waste removal, and reproduction. Infectious diseases. Caused by pathogens that can be spread from person to person. Non-communicable diseases. Long-term conditions that are not transmissible between people. Immune system. Body's complex defense network of cells, tissues, and organs that identifies and fights off harmful invaders. Lymphatic system. A network of vessels and nodes that transport immune cells and filter out pathogens. Weakened immune system. Makes you more susceptible to infections and certain cancers. Autoimmunity. Autoimmunity. The system mistakenly attacks the body's own healthy tissue. Detection. Physical barriers are breached, and innate cells recognize general danger signals from microbes or damaged cells. Activation. Signals trigger inflammation and recruit specialized adaptive immune cells. Targeted attack. B cells make antibodies, while T cells kill infected cells. Memory. After clearing an infection, memory cells remain, allowing for a faster response to future encounters. Matter. Defined as anything that has mass and takes up space. Energy. Defined as the ability to do work or cause change. Conservation laws. In a closed system, the total amount of matter and energy remains constant. Mass-energy equivalence. Albert Einstein's equation demonstrates that mass is a concentrated form of energy. Atoms. Fundamental building blocks of all matter, made of a central nucleus surrounded by electrons. Molecules. Group of two or more atoms held together by chemical bonds. Molecular weight. The sum of the atomic weights of all atoms in the molecule, typically measured in Daltons or atomic mass units. Scale. Most molecules are far too small to be seen with the naked eye. For scale, roughly 100,000 water molecules could fit across a single human hair. Geometry. Molecules have fixed equilibrium shapes such as linear, bent, or tetrahedral determined by their bond lengths and angles. Isomers. Molecules that share the same chemical formula but have different atomic arrangements, leading to distinct properties. Polarity. Molecules can be polar or nonpolar, which dictates how they interact with other substances. Homonuclear molecules consist of only one type of element, such as oxygen or nitrogen. Heteronuclear molecules composed of two or more different elements, such as water or methane. These are also known as molecular compounds. Biological macromolecules. Massive, complex molecules essential for life, categorized into four major classes: carbohydrates, lipids, proteins, and nucleic acids. States of matter. Arrangement and energy of its constituent particles. Solid. Particles are tightly packed in fixed positions, allowing only for vibration. Solids have a definite shape and volume. Liquid. Particles are close together but can slide past one another. Liquids have a definite volume but an indefinite shape, conforming to their container. Gas. Particles are far apart and move rapidly in all directions. Gases have no definite shape or volume and will expand to fill any container. Plasma. Similar to a gas but contains highly energized, charged particles. It is the most abundant state in the universe. Melting. Solid to liquid. Freezing. Liquid to solid. Vaporization/evaporation. Liquid to gas. Condensation. Gas to liquid. Sublimation. Solid directly to gas. Deposition. Gas directly to solid. Ionization. Gas to plasma. Recombination. Plasma to gas. Bond energy. Energy is required to break chemical bonds, while energy is released when new bonds form. Energy transformation. Chemical energy can be converted into several other forms, such as thermal/light, mechanical, and electrical. Electrical energy. Form of energy resulting from the flow of electric charge through a conductor, such as a wire. Static electricity. The accumulation of electric charge on the surface of an object. Dynamic electricity. The continuous flow of electrons through a conductor, used to power our daily technology. Speed. Speed is a scalar quantity measuring the rate at which an object covers distance. Velocity. Vector quantity that describes the rate and direction of an object's motion. Instantaneous versus average. Instantaneous velocity is the speed and direction at a specific moment, while average velocity is a total displacement over a period of time. Acceleration. Rate of change of an object's velocity over time. Standard units. The international system unit for acceleration is meters per second squared. Speeding up. Velocity and acceleration point in the same direction. Slowing down. velocity and acceleration point in opposite directions. Changing direction. Even at a constant speed, an object turning is accelerating. Uniform acceleration. When the velocity of an object changes by an equal amount in every equal time period. Centripetal acceleration. Acceleration directed toward the center of a circular path, responsible for keeping an object in motion along a curve. Instantaneous acceleration. The acceleration of an object at a specific, precise moment in time, often found using calculus as a derivative of velocity. Newton's first law. An object will remain at rest, or continue to move at a constant velocity in a straight line, unless acted upon by a net external force. Newton's second law. The acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. Newton's third law. For every action, there is an equal and opposite reaction. Friction. Force that opposes motion between surfaces in contact, acting parallel to the surfaces, and in the opposite direction of movement. Static friction. The force that prevents an object from starting to move. Kinetic friction. The force that opposes an object that is already sliding. Rolling friction. The resistance encountered when a round object rolls over a surface. Fluid friction. The resistance experienced when moving through a fluid like air or water. Gravity. Fundamental interaction that causes all things with mass or energy to be attracted to one another. Universal attraction. Every object with mass exerts a gravitational pull on every other object. Weakest force. Despite its immense cosmic influence, gravity is the weakest of the four fundamental forces of nature. Space-time curvature. Explains gravity as the warping of space-time caused by mass and energy. Measurement of gravity. On Earth, gravity causes objects to fall with an acceleration of approximately 9.8 meters per second squared. Simple machines. Basic mechanical device with few or no moving parts that changes the direction or magnitude of a force. Lever. A rigid bar that pivots on a fulcrum. Wheel and axle. A wheel attached to a smaller axle, allowing for easier rotation. Pulley. A wheel with a groove for a rope or cable, used to lift heavy objects. Inclined plane. A flat, sloped surface that reduces the force needed to lift something. Wedge. A portable inclined plane, used to split or separate objects. Screw. An inclined plane wrapped around a cylinder, used as a fastener or to lift things. Electricity. The flow of electrons through a conductor, measured in amperes. Electric charge. Matter has a property that can be positive or negative. Voltage. The electric potential difference that pushes charges through a circuit, measured in volts. Chemical reactions. Process where one or more substances, known as reactants, are transformed into different substances, called products. Exothermic reactions. Release energy because more energy is released when new bonds form than is required to break old ones. Endothermic reactions. Absorb energy from the surroundings because more energy is needed to break existing bonds than is released during product formation. Balancing equations. Ensures that the number of atoms for each element is identical on both the reactant and product sides. Law of conservation of mass. States that matter cannot be created or destroyed in a chemical reaction. Change-only coefficients. These are the large numbers placed in front of chemical formulas. Never change subscripts. Subscripts define the chemical identity of a substance. Use the lowest whole number ratio. Final coefficients should be reduced to their simplest integer form. Balance free elements last. If an element exists by itself, balance it last so you can change its coefficient without affecting other elements. Treat polyatomic ions as units. If a polyatomic ion appears unchanged on both sides, balance it as a single group rather than individual atoms. Clear fractions. If you use a fraction to balance, multiply the entire equation by the denominator to get whole numbers. Waves. Disturbance that transfers energy from one location to another without the permanent transfer of matter. Wavelength. The distance between two consecutive identical points, such as from crest to crest or trough to trough. Frequency. The number of wave cycles that pass a fixed point per second, measured in hertz. Amplitude. The maximum displacement of a particle from its rest position. It indicates the amount of energy the wave carries. Period. The time it takes for one complete wave cycle to pass a point. Wave speed. The speed at which the wave propagates, calculated as v equal f times L. Mechanical waves. Require a physical medium to travel. Transverse waves. Particles move perpendicular to the wave's direction. Longitudinal waves. Particles move parallel to the wave's direction, creating areas of compression and rarefaction. Electromagnetic waves. Do not require a medium and can travel through a vacuum. These are all transverse waves. Reflection. Bouncing off a surface. Refraction. Bending as the wave enters a different medium and changes speed. Diffraction. Bending around obstacles or spreading through openings. Interference. When two waves meet, they can add together or cancel each other out. Geology. The study of Earth's solid materials, including rocks, minerals, and the processes that shape the geosphere. Mineralogy and petrology. Study of minerals and rocks. Structural geology. How rocks deform. Sedimentology and stratigraphy. Study of sediments and rock layers. Geochemistry and geophysics. Earth's chemical makeup and physical properties, respectively. Paleontology. Study of ancient life. Meteorology and climatology. The study of the atmosphere, weather patterns, and long-term climate changes. Oceanography. The investigation of Earth's oceans, including marine ecosystems, currents, and the seafloor. Astronomy and planetary science. The study of celestial bodies, solar system dynamics, and the origin and evolution of the universe. Environmental science. The study of human interactions with the Earth and the impact of human activity on natural resources. Fast carbon cycle. Involves the rapid exchange of carbon between living things and the atmosphere through photosynthesis and respiration. Slow carbon cycle. Involves long-term storage in rocks, fossil fuels, and deep ocean sediments. Evapotranspiration. Water evaporates from surface bodies and transpires from plants into the atmosphere as vapor. Photosynthesis. Plants require water to capture atmospheric carbon. U.S. Constitution. The foundational document outlining the framework of the United States government. Bill of Rights. The first 10 amendments to the U.S. Constitution guaranteeing individual rights. Federalism. A system of government where power is divided between a central authority and constituent political units. Branches of government. The division of government into legislative, executive, and judicial branches. Checks and balances. Mechanisms that prevent any one branch of government from becoming too powerful. Citizenship rights. Rights such as speech, religion, and assembly afforded to citizens. Citizenship responsibilities. Duties such as voting, jury duty, and paying taxes expected of citizens. Amendments. Changes or additions to the Constitution. Political parties. Organizations that represent different ideologies and compete for political power. Elections. Processes by which citizens vote to choose their representatives. Public policy. The principles on which social laws are based. Federalist Papers. A collection of articles promoting the ratification of the U.S. Constitution. Declaration of Independence. The document declaring the American colonies' independence from Britain. Supply and demand. The relationship between the availability of a product and the desire for that product. Law of demand. As the price of a good increases, the quantity demanded decreases, and vice versa. Buyer income. Higher incomes generally increase demand for normal goods. Consumer preferences/tastes. trends and cultural shifts that can significantly change demand. Substitutes. If the price of a substitute rises, demand for the original product may increase. Complements. If the price of a complementary good rises, demand for the associated product may decrease. Consumer expectations. Expectations about future prices can influence current purchasing decisions. Law of supply. As the price of a good increases, the quantity supplied increases, and vice versa. Production costs. The costs of raw materials, labor, and utilities that influence supply. Equilibrium price. The market clearing price where quantity supplied matches quantity demanded. Economic systems. Framework societies used to organize production, distribution, and consumption. Market economy. An economy driven by individual and firm decisions based on supply and demand. Command economy. An economy where the central government makes all major economic decisions. Mixed economy. An economy combining free market principles with government regulation. Capitalism. An economic system based on private ownership of production for profit. Socialism. An economic system involving collective ownership of production for the welfare of all. Inflation. A sustained increase in the general price level over time. Deflation. A sustained decrease in the general price level, increasing purchasing power. Business cycle. The fluctuations in economic activity over time, including expansion and contraction. Expansion. A phase of the business cycle where economic activity increases. Trough. The lowest point of the business cycle, marking the end of a contraction. Recovery. The transition from the trough back to expansion in the business cycle.